Question number 5 says we need to find the values of lambda for which the angle between the vectors, that is vector A and vector B, is obtuse. So what are we given? We are given the two vectors, that is vector A and vector B. Vector A is 2 lambda squared I plus 4 lambda j, then plus k. And vector B is 7i minus 2j, then plus lambda k. So we need to look at the solution. Now, we understand that if theta is the angle, we understand that if theta is the angle which is between two vectors, that is vector A and vector B, then we understand that when you get vector A dot vector B, that this will give you magnitude of vector A times magnitude of vector B cos of theta. So if we need to find the angle between two vectors, we use this relation here. And since we are interested in finding the values of lambda for which the angle between these two vectors A and B is obtuse, then we shall need to know the relation which relates the angle between two vectors. And that relation is this one here. Now, for that case, we also understand that from this relation, we can easily say that cos of theta is actually same as vector A dot vector B divided by magnitude of A times magnitude of B. So from here, we can now say that now we are given that theta is obtuse. Now, if theta is obtuse, it will imply that cos of theta should be less than 0. And what does that one imply? This implies that from here, from this expression here, it implies that A dot B, vector A dot B, under divided by magnitude of vector A times magnitude of vector B should be also less than 0. And for this case, it will still imply that A dot B will be less than 0 provided that magnitude of A, also that magnitude of B is also greater than 0. So we shall get the condition, or we shall use the condition that theta is obtuse provided that A dot B is less than 0, for which magnitude of A times magnitude of B is greater than 0. If this is true, then we shall be able to obtain the value of lambda for which the magnitude of, for which the angle between the two vectors is obtuse. Clearly, this will imply that when I get A dot B, the result should be less than 0. But what is A? A is 2 lambda squared for lambda and 1. So we shall dot this one here with B, which B is same as 7, negative 2, and lambda. So the result here should be less than 0. So we shall have 2 lambda squared times 7, which is 14 lambda squared. 4 lambda times negative 2 minus 8 lambda, 1 times lambda, which is plus lambda, and this should be less than 0. This is 14 lambda squared minus 7 lambda less than 0. So we can factorize out 7 lambda, and we remain with 2 lambda minus 1 less than 0. So from here we can say either 7 lambda is less than 0, or 2 lambda minus 1 is less than 0. For this case, lambda will be less than 0, or lambda will be less than a half. Therefore, we shall say that the values of lambda for which this one will be satisfied here should be between 0 and a half, because lambda is less than 0 and lambda is less than a half. Therefore, the required values of lambda should be 0, less than lambda, less than a half. So these would be the values of lambda for which the angle between the vectors A and B will be obtuse. Question number 6. It says the side of an equilateral triangle is increasing at a rate of 2 centimeters per second, and we are required to find the rate at which its area is increasing when the side of the triangle is 20 centimeters. So let us look at the solution. We shall let x to be the side of this equilateral triangle. We shall also let A to be the area of this same triangle. But looking at the information given, we are told that the side of this triangle is increasing at a rate of 2 centimeters per second, and which side we had called x. So this implies that the x dt will actually be 2 centimeters per second. Since we are dealing with an equilateral triangle, it will be important that we also draw this triangle such that we are able to relate the sides and the area. So let us have this triangle which is having equal sides, and since we have let the sides to be, for example, x, it means from here to there is x, from here up to this given point is also x, from here up to there is also x. So if we have our height here, so this would be the height, which we can call h, that is from this given point up to there. So this is the height of this triangle. Now, the required question wants us to find the rate at which the area is increasing. So if we want to find the area at which if we want to find the rate at which the area is increasing, so we shall now first of all need to get the relationship between the area and the sides. So we understand that from area of a triangle, which is same as a half base times height, therefore it is important that we get the height first if we need to relate area with the sides. So let us get the area of the triangle, but first of all we need to find the height of this triangle. So if we need to find the height, we shall first of all extract out this triangle here, this triangle from here to this given point up to this given point. So it means this is h, and this is from here to here is x, then this one will give us x divided by 2, and this is x, which implies that from Pythagoras theorem that h squared plus x divided by 2, which is squared, should give us x squared. For that case, it implies that h squared is actually same as x squared minus x squared divided by 4, which means h same as the square root of 3 by 4 of x squared, which will give us a root of 3 divided by 2 of x. This is our h. So from there, we have got our h as this, and we need to come up with the area. So what will be the area of this triangle? The area will be a half times base which is x from here to there, then times root of 3 divided by 2 of x. This will imply that a quarter times root 3 of x, which is squared, will be our area. So the area is root of 3 divided by 4 of x squared. So we have got our area. We come back to the question. The question requires us to find the rate at which its area is increasing. So if we need to find the rate at which the area is increasing, in other words, we need to get the area dt, the rate at which the area is increasing, and this by chain rule can be related to be the rate at which the area is increasing with respect to the sides, then times dx dt. Since we already have dx dt, so our main interest now will be to find dA dx. Now we already have the area. So we can say from area, which is root of 3 divided by 4 of x squared, it means I can easily get dA dx, that is differentiating this expression with respect to x. So this would be same as root 3 divided by 4 times 2 of x. So this will also be equal to root 3 upon 2 of x. So that is our dA dx, which is root 3 upon 2 of x. Now, let us call this one equation star. So from equation star, we shall have dA dt, which is same as dA dx, that is root of 3 divided by 2 of x, times dx dt, which is given as 2 centimeters per second. So this is 2. So we realize that the 2 will cancel out, we remain with root of 3 of x. That is dA dt, which will be in centimeters squared per second. Now, for x equaling to 10, because we are told that we need to find the rate at which the area is increasing when the side is 20 centimeters. So it means that is when x is 20 centimeters, when x is 20 centimeters, then it will imply that dA dt when x is 20 will be same as root of 3 times 20, and this will be same as 20 root of 3, and this will be in centimeters squared per second. So that will be the rate. That will be the rate at which the area is increasing when the side of the triangle is 20 centimeters.
Yeah.